this conversation about self-reference and physics has me curious about your thoughts on the self and physics in two ways that aren't necessarily connected to self-reference, but where ourselves are very important. And the two things that I have in mind are the many worlds theory of quantum mechanics, where the self is very important, I think, for probability. And then the other thing I had in mind is anthropic reasoning and the multiverse. And we totally don't have to discuss either of these things if you don't want to. But I'm wondering if you have any thoughts on these two areas in the self.
So I think I don't have anything illuminating just because I haven't thought about it carefully about to say about the anthropic stuff. The stuff about Everett and many worlds. Yeah, I mean, it is something that I thought about, and I think it's again just in the spirit of trying to understand. If I imagine myself into a many world setting, I take it sort of on faith that that's the way the world is. How do I understand my own experience? And in particular, how do I understand uncertainty about the future? And I think, I mean, what I say about that, this was like one of my earliest papers in quantum mechanics, like way back before I ever really thought about the self, was focused on that question. And I think it really is, basically what David Wallace and Simon Saunders think. That is, when you're looking into the future, you can't think that there's any objective uncertainty about the way the universe in a third person sense, or the universe intrinsically is. There's got to be some, like, so what's going on there? I'm pre-measurement. I'm going to carry out a measurement. I know that each post-branch version of me is going to be looking at, seeing one, suppose I'm making a measurement in the x direction of a spin half particle. Each version of me, each sort of each one of my post-measurement descendants is going to be seeing a definite result. What kind of uncertainty could I possibly have beforehand? That was the question that I was asking. And I think, I said something false about this the first time I thought and wrote about it. And I needed to think a lot harder about it. But what I said the first time was, well, what I don't know is, I can't remember, what did I say? That's right. I thought that that there could be some sort of pre-measurement uncertainty, and the pre-measurement uncertainty attached to what one would see when one opened one's eyes. And my thought was, look, it's like you have a bunch of, sort of children, and you're sending them off into a jungle, and, there's a certain number of tigers and a certain number of lions and a certain number of, cats. And you're going to give them, they have to have the same credence function. You're going to give them a credence function, given the distribution of tigers and lions and so on, that they're going to see at any, within any interval of time, whether they're going to see a lion or a tiger. So that was my thinking, but I think, in fact, there can't be any pre-measurement uncertainty. And the reason actually has to do with the fact that you have no way pre-measurement of even framing a question about a particular post-measurement branch. So you can't say, I wonder whether the version of me at branch number 1 is going to be seeing, a spin up or spin down, because you have no way of referring to, there's no discriminating relationship that you bear to any one of your downstream descendants that would allow you to frame a question about that branch, de re. If you could, then you could have uncertainty, because you could say, what will the version of me at that branch be seeing? But precisely because of the symmetry of your connections to your downstream descendants, you can't do that. The only way you have of referring to the branches is a spin-up branch or a spin-down branch. So I think the only kind of uncertainty there is post-measurement uncertainty. Before you open your eyes, you can shut your eyes. You are standing at some branch. So you do bear some kind of physical discriminating relationship to the branch that would allow you to entertain a de re thought. I wonder what the result is at this branch. So that's the way that I think of probability from an Erhardt perspective. And one way the kind of cute way of phrasing it so that it's not about uncertainty is you can phrase it as surprise. How surprised should I be that I'm seeing, given my pre-measurement state, how surprised should I be that I'm seeing spin up rather than spin down? And you can also put it not in terms of uncertainty, but in terms of a kind of internal indeterminism. You can say, what is the... Is it possible to predict my post-measurement state from my pre-measurement state for a given me? And the answer there is no, even though the laws are deterministic. So again, a way of seeing the not quite uncertainty, but surprise or indeterminism arising from an internal perspective.
I'm curious about the spirit in which you're thinking about probability from the Erhardt perspective. So you mentioned David Wallace and Simon Saunders, and you're at Johns Hopkins where Sean Carroll is now, and he's a very outspoken advocate of many worlds. So I'm wondering if you're thinking about probability or solving probability in the spirit of somebody who's just interested in the implications of the various interpretations of quantum mechanics, or if you're trying to solve these problems because this is the interpretation that you advocate for as most promising.
The truth is I don't have a dog in that fight. I mean, there are, yeah, so I really don't. I think if you're an Everettian, you should think of probability in a self-locating way, as David Wallace and Sean and Simon Saunders do. So that part I think is right. What do I believe about the foundations of quantum mechanics? I think what I just said a minute ago about the participatory stuff might be the right way to think about it, but I don't have strong. I feel like we don't understand. I feel like we will know when we have the right interpretation, and none of the ones that we have right now seem right. They're all illuminating in different ways. I definitely don't like the Bohemian view. It doesn't seem natural at all to me. I don't have much more illuminating to say. I see I wrote a paper arguing that David Albert's style, space-time is not fundamental, was the right way to think about it. I've written about the Erhardt stuff. I'm going to write this thing on the participatory stuff. So I don't know that we are even close to really understanding it right now. And that any one of these is the full and complete and final story about it.
Okay, very interesting. I think it was Tim Maudlin I was talking, who, as you know, is a very devout Bohemian, who said that there are 3 theories or interpretations, though, that are the only dogs in the race, to use your phrase. That's many worlds and spontaneous collapse theories, and then Bohemian mechanics. Should I interpret you as saying that you don't think any of these 3 is the correct one or the most promising one, even they're not fully developed, or just that you don't want to pick one of these 3 or their future descendants and variants?
I think there are ways. So it depends what you mean by the Everettian. I feel like when we when we do fully understand quantum mechanics, we will see how it's a version of the Everettian theory. You can see Bohmian mechanics in it. It's also a version of, I mean, it didn't seem to be on Tim's list from what you said, but I think also see the sense in which space-time is not fundamental, which is like David Albert's style quantum mechanics. So I don't feel like, at least in my mind, that I've attained the kind of clarity